In example 2, we were using the part 1 of the fundamental theorem of calculus, where the integral and the derivative undo each other. For example 3, we're going to use part 2, where the antiderivative, where the area underneath the integral or the definite integral is going to be the same as the displacement or the difference in the antiderivative function from the beginning, the lower bound to the upper bound. So here we have this function, sine x plus 2e to the x, and we want to find the area under that curve from 0 to 1. To do that, we're going to first of all anti-differentiate this. So the antiderivative of sine works out to be negative cosine x, plus the antiderivative of 2e to the x is itself. And then we're going to evaluate this from the bounds 0 to 1. So plugging in these bounds, we're going to end up with negative cosine of 1 plus 2e to the 1 minus negative cosine of 0 plus 2e to the 0, which is just going to be 2. So simplifying this, I get negative cosine of 1 plus 2e minus, well, cosine 0 is 1, so I get negative 1 plus 2. So I end up with minus 1, and I end up with 2e minus 1 minus cosine of 1, and that represents the area underneath the curve. For this one here, we're going to do the same thing. So we're going to take the antiderivative function. So cotan x cosecant x is the derivative of negative cosecant. So we're going to use negative cosecant as our antiderivative function. And we're going to evaluate this from pi over 4 to pi over 2. Plugging these in, we get negative cosecant of pi over 2 minus negative, so plus cosecant of pi over 4. Okay, the cosecant of pi over 2, well, we can think of it as a sine function. Sine of pi over 2 is 1, so the reciprocal of 1 is 1. So we end up with negative 1 plus pi over 4 is going to be 45 degrees, so it's going to be here. The sine of pi over 4 is going to be 1 over root 2. So the reciprocal is going to be root 2 over 1. So the area works out to be root 2 minus 1. So the area underneath this curve is going to be this area here. It's going to be units squared.